Students, good morning. Our next chapter is determinant. In the previous chapter, matrices, we studied types of matrices. Okay, under that, again we studied square matrix. Square matrix means in a matrix, number of rows is equal to number of columns. Okay. Now see, determinant is related to square matrix. Determinant means every square matrix is associated with some real numbers. That real number, particular real number is called determinant of the given square matrix. Okay, I'll write the definition. Every square matrix with the real entries is associated with a real number. Okay, and this real number is called determinant of the given square matrix. Here important condition is square matrix with the real entries. Real entries means real numbers. Okay, and okay, for example, see, if A is a square matrix, A is a square matrix, then determinant of A, so the given matrix A is denoted by either you can use this symbol, we called it as delta or determinant, or determinant of A, or one more symbol like this. Okay, determinant A. Okay, these are notations. You can use delta, or you can write DETA, that represents the determinant of A, or this symbol determinant of A. Okay. The next step, how to calculate determinant of square matrix. Square matrix, see, order 3 square matrix is there, order 2 square matrix is there. Okay, some methods are there how to calculate that particular real number. Okay, given square matrix is associated with one particular real number, we called it as determinant. Okay, to calculate determinant, some particular methods are there. Okay, see one by one. First, see how to calculate determinant of the matrix of order 2. Next step, how to calculate the determinant of the square matrix of order 3. Okay, determinant of a square matrix of order 2. Okay, suppose I am taking one matrix A is equal to A1, B1, A2, B2. Okay, this say one square matrix of order 2. Here you can see 2 rows and 2 columns are there. Okay, now delta, that represents determinant of this matrix, you can write it as A1, B1, A2, B2. Okay, in the next step, this determinant value is first to multiply principal diagonal entries. What are the principal diagonal entry here? See, A1 and B2, right? Multiply, you will get A1, B2, next minus. Okay, this is by formula, minus, then non-diagonal entry. So what's a non-diagonal entry? B1 into A2. Okay, you need to write product of non-diagonal entry. So you will get here B1 into 8. Okay, this is the determinant value of the square matrix A with entries A1, B1, A2, B2. Okay, that means product of principal diagonal minus product of the non-diagonal. Clear? A1, B2 minus A2, B1. Okay, first you need to take the product of the principal diagonal only, then product of the non-diagonal. Product of diagonal minus product of non-diagonal. Okay, it's a formula to calculate the determinant of a square matrix of order 2. Okay, see one example. Matrix A is equal to 1, 2, 3, 4. Okay. Question is calculate the determinant of this matrix. I am writing determinant of A is equal to, first see here you have to write 1, 2, 3, 4. This is just a notation, determinant of A. That is determinant of 1, 2, 3, 4. What's the procedure? First multiply the principal diagonal entry or diagonal entry. 4 into 1 it's equal to 4 minus product of non-diagonal entries. What's the non-diagonal entries? 3 and 2. What's the product? 3 into 2 it's equal to 6. Okay. Then subtract 4 minus 6. Its value is equal to minus 2. You can clearly observe now. It's a real number. Minus 2 is a real number. See, this particular square matrix is associated with one real number, that is minus 2. This minus 2 is called the determinant of the given square matrix A. Okay. Next is how to calculate the determinant of a square matrix of order 3. Okay. First write one square matrix. A is equal to A1, A2, A3, B1, B2, B3 and third row C1, C2, C3. It's a square matrix of order 3. Okay. Then you need to calculate determinant of A. Okay. You need to calculate. Here I will write determinant of A is equal to determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. The next step, see, to calculate this determinant, here I will put alternative plus, minus, plus. Okay. Just assume this plus, minus, plus. Okay. The next step, see, it's equal to, first consider element A1. It's in the first row and first column, right? So, A1 into, or here I'll write A1 into, cancel first row and first column. Okay. What you will get here? Here you can see one square matrix or one determinant with B2, B3, C2, C3, right? So, here I'll write A1, cancel corresponding row and column, remaining is determinant B2, B3, then C2, C3. Okay, it's a first entry. Then see here minus. What's the second entry? That is A2. Okay, same procedure. See here A2 is in the first row and second column. So, delete first row and second column. So, A2 into what is remaining? Here see, you can see determinant. Here P1 and here C1 is there. B1, B3, C1, C3 is remaining. Okay. Then plus. What's the element? A3. Now which row and which column we need to delete? See here. First row. A3 is in first row and third column, right? Third column. So delete first row, third column. Here you can see one set of determinant. That is determinant B1, B2, C1, C2. Okay. Now see, in the previous step we studied how to calculate the determinant of the square matrix of order 2. See, A1, B1, A2, B2 means product of diagonal entries minus product of non-diagonal entries. Okay, or product of principal diagonal minus product of non-diagonal. Okay, here similarly A1 into, it's a square matrix of order 2, right? 2 rows, 2 column. What's the determinant? B2 into C3 minus B3 into C2, right? Diagonal entries minus non-diagonal entries. Okay. Next, minus A2 into, again it's a square matrix of order 2. Calculate the determinant. First, product of diagonal entries, that is B1 into C3, minus product of non-diagonal entries. You can write B3 into C1, or you can write C1 into B3 also by commutative property. Okay. Last entry C plus A3 into, again see, first product of the diagonal entries B1 into C2 minus, what's a non-diagonal entry, C1 into B2. This is a determinant of the given square matrix of order 3. Clear? First, one square matrix of order 3 is given. Write it in determinant notation. Determinant is A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. Above the determinant, in the first row, in the corresponding element, put alternative plus, minus, plus for your reference. Okay. A1 into, delete first row here and first column. What you will get here only? B2, B3, AC2, C3. Here I will write. Then minus here A2, here A2. See, A2 in first row and second column. So delete first row, second column. You will get only B1, B3, C1, C3. Plus A3, it's in first row, third column. So delete first row, third column. What is remaining? B1, B2, C1, C2. Okay. Here write. Okay. Now see, all these determinant are of order 2. We already know how to calculate. Product of diagonal minus product of non-diagonal. Okay, just calculate and substitute. That gives the determinant of the square matrix of order 3. Okay, we'll solve some problems. That time we come to know how to calculate. Okay. See the problems. First is 2, 3, 1, 4. Need to calculate the determinant. Clearly it's a square matrix of order 2. So it's equal to product of diagonal 4 into 2, 8. Minus product of non-diagonal 1 into 3, it's equal to 3. 8 minus 3, its value is equal to 5. Okay. Next, here's in the second problem 2, 0, 0, 5. Product of diagonal 5 into 2, it's equal to 10. Minus product of non-diagonal 0 into 0, it's equal to 0. 10 minus 0, its value is equal to 10. Third, see, product of diagonal 1 into 1, it's equal to 1. Minus 0 into 0, it's equal to 0. 1 minus 0 equal to 1. Okay, this is how to solve or how to find the determinant of square matrix of order 2. Okay. Now go to the next problem. That is, I'll take fourth problem. It has calculate the determinant of 1, 2, 3, 0, 1, 2, 1, 1, 1. Okay. See, what's the first step? Here put plus, minus, plus. Okay. Now calculate. What's the first step? A1, right? First element 1 into, or here right, 1 into, cancel this row and this column. Okay. Here row and column, cancel that row and column. What you will get? Determinant 1, 2, 1, 1. Okay. Next, minus 2 into, cancel see first row and second column. What you will get? Determinant 0, 2, 1, 1. Okay. Next, see plus 3 into, cancel this column, third column and first row. What is remaining? 0, 1, 1, 1. Okay. Now calculate the determinant. It's equal to 1 into any number is same number. So 1 into 1 minus 2, right? 1 minus 2 minus 2 into product of diagonal 0 into 1 it's equal to 0 minus 2 into 1 it's equal to 2 plus 3 into 0 into 1 is 0 minus 1 into 1 equal to 1. Okay. Now simplify 1 minus 2 minus 1 minus 1 into 1 it's equal to minus 1. Then 0 minus 2 minus 2 minus 2 into minus 2 it's equal to plus 4. Okay. Then 3 into minus 1 it's equal to minus 3. Okay. Now simplify minus 3 plus 3, right? Minus 3 plus 3 its value is equal to 0. Clear? See the next question. Calculate the determinant of this matrix. Okay. First step is put plus minus plus. First entry is 2 into. Okay. Now see, you need to cancel this row and this column. Okay. What you will get? 4 5s are 20 minus 1 into 0 here plus 0 because already one minus is there in the formula. Okay. Then say second entry is minus 3 into you need to cancel this column, right? So what you will get? 3 into 5 15 1 into 0 minus 0. Okay. Then see next entry plus, but here entry minus is there. Plus into minus, here you will get minus 2 into next this column you need to cancel. What is remaining? 3 into minus 1 minus 3 1 into 4 minus 4. This minus by the formula. Okay. Now simplify. It's equal to 20 2s are 40 minus 15 3s are it's equal to 45. Okay. Minus 3 minus 4 minus 7 into minus 2 it's equal to plus 14. Okay. Here see minus 5 is remaining. Minus 5 plus 14. Okay. Simplify this. Plus 9 is the answer. Okay. Therefore 9 is the determinant of the given square matrix. Next problem. Calculate the determinant of this square matrix. Here see two entries are zeros are there, so it's easy to calculate the determinant because we know 0 into any number is equal to 0. So first entry see 2 into, okay, calculate the determinant cancelling row and column. 4 5s are 20 minus 0. What is next? Minus 0 into some number, right? I'll write minus 0 into, cancel first row and second column. What you will get? Okay, 0 into 5 is 0, 0 into 0 is 0. Okay. The next step see plus 0 into, okay, you need to cancel first row and third column. What you will getting? 0 into 0 0, 0 into 4 also is equal to 0 minus 0. So here 20 into 2 is 40 plus 0, its value is equal to 40. Determinant value is 40. But see here entry 0 is there, no need to calculate further values here. Why? 0 into any number is 0. So directly here you will write plus 0. Here also see 0 into any number. 0 into any number is equal to 0. So you can write directly it's equal to 0. So if here these two entries are 0, it's enough to calculate only first entries. See the next question. Determinant x for 4x is equal to 0. We need to find x value. Okay. See, first you need to calculate the determinant. Okay, you can't write x is equal to 0 directly because it is not a matrix. See, this matrix is equal to 0. 0 means that time that is a 0 matrix. All elements are 0. That time comparing you can write x is equal to 0 directly. But observe the notation clearly. Here matrix is not given. Here determinant is given. So you need to find the determinant first. It's a see matrix of order 2. How to calculate the determinant? Okay, product of diagonal minus product of non-diagonal. So x into x, x square, 4 4s are minus 16 is equal to 0. It's not a matrix. Why? It's a determinant. Okay, definition itself says na determinant is a real number. So it's a real number 0. Okay. Now x square, shifting minus 16 to right hand side, you will get plus 16. Square, x square is equal to 16. What's the possibility? Okay, x is equal to plus or minus 4. Why? 4 square is 16, minus 4 square also 16. Whenever x square equal to 16 or x square equal to 9 comes, you need to use plus or minus. Degree 2 means there exists two solutions, right? Therefore, x may be plus 4 or x may be minus 4. It's a very important case. You need to write x is equal to plus or minus 4. Otherwise, your answer is wrong. Clear? Similar to previous question. Determinant x7, 7x is equal to 0. Question is again find x value. Okay. Simplify x into x square minus 7 into 7 it's equal to 49 is equal to 0. X square is equal to shift minus 49 to that side, it's equal to plus 49. X square is equal to 49. That means x may be plus 7 or x may be minus 7. So you can write x square is equal to plus or minus 7. Okay, x is equal to plus or minus 7. X square is equal to 49. That means x may be plus 7 or x may be minus 7. But it's very important. You need to write plus or minus 7. This is all about how to calculate the determinant of the square matrix of order 2 and order 3. In the next session, we will solve some exercise problems. Okay. Thank you.